The AVPro Edge AC EX40 444 Plus kit is an 18 gigabit per second HDMI extender that uses HD-based technology. It can deliver a virtually lossless high bandwidth 4K HDR signal with support for all signals up to 18 gigabits per second. Deep color and HDR metadata remain intact, making the image free of artifacts like banding. This kit also supports a lot of other features such as audio extraction, IR extension, RS-232 extension, EDID management, audio return channel, built-in scaling, and built-in test patterns that can be used for troubleshooting. Let's take a look at the installation. Thanks for checking out this training module on the AVPro Edge AC EX40 444 Plus HDMI extender kit. By now, you should have already watched the video on the AC EX40 444 kit. And if you haven't watched that video already, we do recommend that you watch that one before diving into this video. One thing that you'll notice is that there's not much of a difference between the two kits when it comes to installation and setup. In this video, we'll concentrate on what's different when comparing the AC EX40 444 kit to this AC EX40 444 Plus kit. Both kits support EDID management, video downscaling, and can generate test patterns for setup and troubleshooting. Even though they both support these features, the way you set those features up is a little bit different when comparing the two kits. One of the biggest advantages of the AC EX40 444 Plus kit is the addition of ARC, or audio return channel, and also USB extension. Let's take a look. First, let's take a look at the EDID management on the transmitter. Now, you'll notice on the transmitter on the top, you have the key here for EDID, the scaler, and test pattern generation. We're going to concentrate on the EDID stuff first. So there's 5 dip switches that are on the side of the transmitter, and that's what we're going to use for EDID management, specifically the first 3 dip switches. So one thing you'll notice from the factory is the EDID comes in bypass mode out of the box. So that's 0, 0, 0, and the first 3 dip switches are all in the up position. So that means the EDID is being bypassed. Now let's say, for example, you might want to use a 1080p 2-channel EDID. If we take a look at the key, that's 0, 0, 1. So the first 2 dip switches are in the up position for 0. We're going to put the 3rd dip switch in the down position for 1. Now we have a 1080p 2-channel EDID for the display. Now, as you can see here, there are several different built-in EDIDs that you can use, but there may be a time where you want to copy an EDID. To do that, we're going to put the first 3 dip switches in the down position. Now we're in the user EDID mode. To copy the EDID from the display or the AVR or whatever you're plugged into, make sure we're in the EDID copy mode, so first 3 dip switches are down. Now we're going to take this 5th dip switch and we're just going to toggle it down and then back up again. By doing that, we've just copied the EDID into the transmitter. Now to bypass all the EDID management, simply put all the dip switches back into the up position. Next, we'll take a look at the scaler. Now you'll notice the scaler is only going to be using dip switch number 4. With the scaler in bypass mode, dip switch number 4 needs to be in the up position, which is exactly how it comes from the factory. But let's say you have a 4K signal, but the display is only 1080p, you can downscale the signal simply by flipping dip switch number 4 into the down position. Now the 4K signal has been downscaled to 1080p, which you can see on the little test monitor here. And to turn the scaling back off again, go ahead and flip up number 4 dip switch into the up position, and now the 4K signal will come through as 4K. Next, we'll take a look at the test pattern generator. Now, right now, we are going to send out a test pattern from the transmitter. So this will test the signal chain between the transmitter and the display itself, and anything in between. So to turn on the test pattern, we're going to take dip switch number 5 and flip it into the on position. And as you can see on the screen right now, we have a test pattern with some color bars. To turn off the test pattern generator, flip that switch back up into the up position. If needed, you can also send out test patterns from the receiver, and that'll test the link between the receiver and the display. So to do that, go ahead and pull power, and we're going to press and hold the setting button on the receiver. while plugging power back in. Wait a few seconds, and there's a test pattern on the receiver side. And again, to exit test pattern mode, go ahead and pull the power and plug it back in. Next, we'll take a look at some of the audio features that are included with this kit. First things first, there may be times where you need to get the audio signal from the display all the way back over to the rack where the AVR most likely lives. So if you want to use the optical output on the TV, that'll take care of all the audio from the internal tuner, from streaming apps and things like that. We'll take an optical cable and we'll plug into the optical output on the TV. We'll take the other end of that optical cable and we're going to plug into the digital audio input on the receiver. Then we would take a second optical cable, plug it into the digital audio output located on the transmitter, and the other end of that optical cable will go into the AVR. Now keep in mind, if you're going to send audio over the optical connection, there's a switch on the front of the transmitter and receiver. On the receiver, the switch is labeled audio in, and you can select either ARC or TOS. We need to flip that switch over to TOS. And then on the transmitter, we're going to do the same thing. We're going to set the audio output over to TOS. Now, any audio signals that are coming out of the optical output of the television are going to come into the receiver, then travel down the HD-based T-Link into the transmitter, and then we're going to come out of the transmitter into the AVR. Now, the other way to get audio from the receiver side to the transmitter side is through audio return channel, or ARC. Now, keep in mind, if you're going to use ARC, make sure that the display supports it, make sure that the AVR supports it, and on some displays, you may need to do something to activate the ARC or to turn it on. Could be a specific input as well, so double check that. So if we're going to send audio over the ARC channel, we can flip the switch over to ARC. So the audio in is set to ARC on the receiver, and the audio out on the transmitter is also set to ARC. Now we can ditch the optical cable. We're not using that anymore. And again, as long as you're plugged into the correct input and the ARC is set up correctly on the display, that any audio coming from the internal apps from streaming or perhaps from the internal tuner, those HDMI audio signals will come into the receiver through the HD-based T-Link into the transmitter, then out of the transmitter into the AVR. Again, one last time, just want to make sure, because this will not work if you do not flip the switch on both the transmitter and the receiver over to ARC. Another great feature of this kit is the bi-directional USB extension. So what this means is we can take a USB device that could be a USB camera or any other USB peripheral that you can think of. We can send those USB signals from receiver to transmitter or transmitter back to receiver. A couple things to point out on the transmitter and receiver, both of them have a USB-B type connector to plug into a PC. So for example, on the USB host port on the transmitter, I could plug the USB-B cable in here, and then we can plug the other end into a PC. Now on the receiver side, I could plug in something like a USB camera or a keyboard mouse, or again, any kind of USB peripheral that you might want to use. That's going to plug into the USB device ports. There are two of them on the receiver. You can plug into either two. Now from here, anything you do with that USB signal, that's going to make its way from the receiver through the HD-based T-Link into the transmitter, and then out of the transmitter into the PC. Now you can do this the opposite way too. Let's say you had a USB-powered camera on the transmitter side, and you wanted to connect that to a PC that's near the receiver side. We can do the exact same thing. We'll take that USB-B cable, and we're going to plug it into the USB host side on the receiver, and the other end, the USB-A cable, will plug into the PC. Now, any USB signals coming from here will make their way over to the receiver. Now, there is one thing that I do want to point out when you're setting up the system like this. On the back of the receiver, there is a switch that says USB direction select. And there's 3 positions for this switch: host, auto, and device. If the PC is plugged into the receiver, we want to have the switch set to host. If the PC is plugged into the transmitter, we want to have that switch set to device. There is also an auto setting right in the middle, which should auto detect where the PC is versus where the USB peripheral is. The last feature that we're going to look at today on this kit is the HDMI local loop out that's located on the transmitter. There's an HDMI output right here. Now that local loop out can be used for a variety of different things. If you wanted to split the HDMI signal to separate the audio from the video, maybe to send the audio to an AVR, you can certainly do that. Or maybe you have a confidence monitor in the rack. You can use the HDMI output on the transmitter to feed the confidence monitor. This can be very helpful if you're building a rack and you want to be able to monitor the system. The last thing we're going to look at today are the status lights on the transmitter and receiver. These lights can help you troubleshoot the system or even troubleshoot the kit itself. First, we'll take a look at the transmitter. First, you have a red power light, and as long as the unit has power, that should be solid red. Next is the AV activity light. That should be blinking blue. That means there's audio-video data coming through the kit. Next is the HD-Base-T light. That should always be solid blue. Then we have the HDMI light. That should also be solid blue. These 2 lights mean that there's a solid connection, HD-Base-T to the receiver and HDMI over on the source. On the back of the unit, there's a couple of lights that you can use for HD-Base-T. There's a solid green light. That means that there's signal coming through. And there's a blinking orange light. That means that there's power coming through the kit. The orange should always be blinking. The green should always be solid. Take a look at the receiver next. Very similar. Power light should always be red. The AV activity light should be blinking. HD-Base-T light should always be solid. The HDMI signal light should also be solid. And on the back of the unit, just like on the transmitter, we have a blinking orange light for HD-Base-T and a solid green light for HD-Base-T. If you're having problems troubleshooting the kit, you can always give us a call at 605-274-6055. Thank you so much for watching this video on the AVPro Edge AC EX40 444 Plus kit. We hope you found it informative. If you have any questions on installation or about any of the features that we talked about today, feel free to give us a call. Again, that number is 605-274-6055. We'll see you on the next one.